All right, this is just going to be the guide for the makeup, the energy makeup test. So I'm assuming you're following along with the actual test. If you don't have the test, something went wrong. All right, something went terribly wrong. But again, you shouldn't only be having the test. I mean, this makeup without a test, because you do need to see the answer choices. So let's actually get started. Now, number one says which graph best represents the greatest amount of work done. So what is the formula for work? And we know that the formula for work is force times distance, all right? And so now we've answered the first problem. So how do we calculate area of a graph? Well, the area of a graph is base times height. Well, what's your base in the graph? Your base in this graph is your force. Actually, that's false. Your base in this graph is distance, right? And your height is going to be your force, okay? Now, what is the area of this graph equal to? So what is the area of graph equal to? If you know your area is distance times force, and I'm gonna rearrange this a bit. If you know your area is force times distance, well then you know your area is your work, right? So the work. So what is the area of a graph equal to? Well, the area of a graph is equal to your work. All right, so which graph gives you the greatest area? So you know that a triangle cannot give you a greater area than a square, and you know that half a square is not going to give you a greater area than a square. So you know that the full square is the greatest area. All right, and so let's do number two. A horizontal force, what are your three knowns? Well, you know your uh, first known is your force, which is 50 newtons. You know your mass is 20 kg, and you know your distance is 10 meters. So what is the total work, right, done? So that's what you want to solve for. You want to solve for total work. And what's the formula for work? Well, your formula for work is F times D. And so now you're going to solve this. So W is equal to 50 times 10, and you get 500 joules. 500 joules, all right? Now, now, if the time required for a student to swim 1,000 meters is double, the power developed by the student will be what? So what is the formula for power that involves time? The formula for power that involves time is gonna be work over T. All right, and so, well, assuming you got the correct formula, which is this, well, what happens if you double this time, right? So if we, again, you guys can't really work well without substituting numbers. So let's assume W is 2, and let's assume time is 1. And you get 2 here, so you get a power of 2 watts. That's the original power. Well, if you double the time on the bottom, you get 1 doubled is going to give you 2. And so now your new power, right? Your new power is 1 watt. And so your power output halved, okay? Power output halved. All right, 4. Now, what are your three knowns? All right, so your mass is 80 kg. Your vertical distance is 2 meters, and that's really your height, right? That's your height. And your time is 10 seconds. So these are your three knowns, and what do you want to solve for? You want to solve for your total work done against gravity. So that's you want to solve for work. And we know the formula for work is force times distance. And you're missing your force in this problem, right? We have D, we want to solve for W, but we don't really have F here. Well, guess what, right? Our F is our force due to gravity, and so your force due to gravity is mass times gravity, and so your mass is going to be 80 and G is going to be 9.8. Let's actually round this to 10, so you get somewhere around 800 newtons. All right, now that you have FG, what you want to do is you want to solve for work. All right, now you have the FG, so W is 800. right? All I'm doing is substituting F into work. So again, if I were to show all my work right there, D is going to be 2, and I'm going to get 600 joules right there. And so that's my answer. Now number 5. Well, your two knowns, so you know your weight, right? You know your weight is 9 times 10 to the 2 newtons. And you climb at a speed of 3 meters per second. And develops power at a rate of what? So you want to solve for power. Alright, again, we know that weight is synonymous with force due to gravity because that's what's pulling you down. That's basically what your weight is. So what is the formula for power that involves your knowns? Well, the only formula for power that involves your knowns on your reference table is this. Right, F times V. And so all you're going to do now is, well, guess what? We're just going to substitute and solve. So this is 27 times 10 to the 2, which is 2.7 times 10 to the 3. All right. Now number 6. The electrical heater raises the temperature of a measured quantity of water. The water absorbs 6,000 joules of energy. All right, so your uh, work done, right? Because work is measured in joules, is 6,000 joules. So in 15 seconds, so your time is 15 seconds. So what is the minimum power supplied to the heater? Well, these are your two knowns. Uh, what do you want to solve for? You want to solve for power, right? And so the formula that involves power is this. And now all you're gonna do is substitute the numbers, and wow, we got the answer. So this is gonna be 400 watts, because that's how power is measured. Now, number 7 was the maximum height. So you want to know what your three knowns are. So your power is 20.4 watts. Your mass is 5 kg, and your time is 10 seconds. And you want to solve for height, right? You want to solve for height, or you want to really just solve for distance. Now you're lifting something, so and you're missing Fg in your known. So assuming you did question number 4, we know that my force is Fg, right? I'm lifting something, so there's a force due to gravity acting on it. Now my mass is given, right? My mass is given up here, it's 5, and my g is 9, and so my force due to gravity is 50 newtons. Now that you have Fg, what is the formula that involves Fg, P, T, and D? And so the formula that involves that is this right here on your reference table, right? And there's no G here, but it's just F actually. And so let me just make that a bit more clear. So it's FD over T. And so F is 50, D is what we want to solve for, and we know what T is. T is 10. And I'm actually going to replace the P over here to be 20.4 watts, all right? So 10 times 20.4 is going to give you 204. Again, I'm multiplying by 10 on both sides. We know that this cancels out. So now I get 50D, and so I divide by 50, and I get somewhere around 4 meters, all right? I get somewhere around 4 meters. And so now we do 8. So when a mass is placed on a spring with a spring constant of 15 newtons per meter, so my K is 15 newtons per meter, spring is compressed 0.25 meters. How much elastic potential energy? Right, so what is that? And so my two knowns are these, and I want to solve for PES. And so the formula for potential energy of a spring is on your reference table is that. So 1/2 15, x is 0.25 squared, 1/2 7.5, 0.25 squared, it gives you 0.625. You're gonna have to use a calculator for this. Actually, let me solve it. Let me solve it real quick. So 7.5 times 0.25 squared is going to give you 0.46875. And we'll round that to actually 0.47. And I think that's the answer, right? I think that's 0.47 joules. I think that's the answer. Hold on. Yeah, that's the answer. Now, Let us do number 9. So the diagram represents a spring hanging vertically that stretches 0.075 meters. 0.075 meters, and there's a 5 Newton weight attached. So my Fg is 5 Newton. So these are my two knowns, and so weight is synonymous with Fg, which is written on these prompts. So what do you want to solve for? Right, the value of the spring constant. That's what you want to solve for. So what is the formula that involves spring constant and your other knowns? Well, if you look at your reference table, you get this, right? So F, force on a spring, is Kx. And we know that the force on the spring right now is my force due to gravity. So I'm going to do 5 is equal to K, 0.75. And I'm going to divide this right here. And I'm going to get my K is going to be equal to 0.075 is 66. 66.7 newtons per meter. And I think that's the answer. Now let's do number 10. Give me a second. There's gonna be a pause. You can just skip forward probably. Alright, let's go to number 10. As the pendulum swings from position A to B, what is the relationship of kinetic energy to potential energy? So again, this is conservation of energy problem. Let me actually pull up the uh, image. So again, we kind of covered this in the given. I showed you in the PowerPoint slides if you were paying attention, right? So at this point in time, you have a lot of potential energy. You actually, let's say you have uh, 4 blocks actually of potential energy here, right? So you have 4 blocks of potential energy, and you're not moving right now, so you have no kinetic energy. And so all the way at the bottom, all the way at the bottom, well, now all your potential energy has turned into kinetic energy because, well, eh, we can assume that the height here is, well, all the potential energy here has turned into kinetic energy. So now there are 4 boxes of kinetic energy, and so your potential energy is 0 here. Okay, so what's gonna happen as the pendulum swings from point A to point B, right? Your potential energy decreases while your kinetic energy increases by the same amount, right? It goes from 0 to 4 boxes, while your potential energy goes from 4 boxes to 0. So your kinetic energy here increases, and your potential energy here decreases. Okay. Uh, 11. In this diagram, a mass is 2 kg, and the gravitational potential energy system to be 0 at E. The maximum height will reach above point E is closest to what? Now, I showed you this on the PhET simulation. If you want to see the PhET simulation, you can just Google PhET um and conservation of energy. I think it's either that or internal energy, conservation of energy. And if you release, let's actually think about this for a second. If I release a ball, right, and let's assume that it's never gonna lose energy. It's never going to lose energy due to internal energy. If I release a ball down here, what's going to happen as it hits the ground is it's going to come back up. And if it doesn't lose any energy due to heat or anything else through the sound, well, the ball is going to come back up to the same exact height. All right. And if you look at your question, if you look at your roller coaster on your test, well, if you kind of think about, well, this is not exactly the same roller coaster. I made a much more simplified roller coaster. If you just put your ball here, right, and you release it, and you release it, y- the ball is just gonna come back up to the same exact height because there is no friction in this problem. Well, uh just because you make the track a little bit different doesn't mean it won't come back up to the same height anymore. Right? As the ball goes from here to here, so now let's say the potential energy here is like 50 and well, now your potential here energy here is 0, but your kinetic energy here is 50. Let's say up here your kinetic energy is 20, right? Your kinetic energy here is 20 and your potential here energy here is 30. Your energy is still conserved, you're not losing anything, right? And then as your ball goes up here, what's going to happen is that your potential energy is going to come back to 50. And your kinetic energy is still going to be 0. So it's going to come back to the same exact height no matter what, as long as you don't have friction. 12. At what point in its fall does the kinetic energy of a freely falling object equal its potential energy? At what point in its fall? So let's take a look at this one. Let's say we have a ball here, and the potential energy is 2 blocks, right? So well, the potential energy is 4 blocks, sure. And all the way down here, my potential energy is 0, right? There's no blocks there. But all the way just before it hits the ground, my kinetic energy is still 4 blocks, right? All the potential energy is transferred into kinetic energy. Well, at what point are these two energies equal? Well, let's think about it. As we get here, as we let's over here. Let's say as let's actually redraw this. And my potential energy at this point in time is just maybe, let's say it's that. Well, where did the energy go? Right? Well, it went to kinetic energy because it's moving. It's on its way down. It's moving, so it has kinetic energy. Well, let's say you're at the midpoint now. How many blocks do I have? Well, I have 2. And well, where did that extra block go? Well, it went to my into my kinetic energy, and so my potential energy and kinetic energy is now equal. So this is the answer to the problem. So halfway between the start and the end. All right. So that answer is number 12. Number 13. So it says a 20 kilogram object, 20 kilogram object strikes the ground with 3,000 joules of energy after falling freely from rest. Okay. And so your initial speed is 0. So this is at the bottom, so it gains that much kinetic energy as it hits the bottom. So your total energy at the bottom must equal to your total energy at the top. So what is your kinetic energy at the bottom? Well, your kinetic energy at the bottom is this right here, this number right here, 1960 joules. Now, what is the formula for gravitational potential energy? We know the formula for gravitational potential energy on your reference table is FGH. So what is your height at the bottom? Well, your height at the bottom is 0, right? This is not the bottom. What is your potential energy at the bottom? Your potential energy at the bottom is 0 as well, because if your height is 0, well, then your potential energy is 0. So my total energy at the bottom now, right? If we do P plus KE, well, if at the bottom my potential energy is 0 and at the bottom my kinetic energy is 1960, well, then my total energy at the bottom is 1960 joules. Well, then and this is at the bottom. Well, we know by the law of conservation of energy, your energy at the top must equal to your energy at the bottom, and so your energy at the top is also 1960 joules. And so let's actually get rid of this. That's actually the only thing we're going to carry over is that energy at the top is 1960 joules because that's the conservation of energy. Now, now we can. So what is your kinetic energy? My so what is the formula for kinetic energy? So kinetic energy, the formula for kinetic energy is 1/2 mv squared. So what is your velocity at the top? And it gives you velocity at the top because your velocity at the top, if you're starting from rest, you're starting at a velocity of 0. Now, but if your initial velocity at the top is 0, then your kinetic energy now is 0 as well. Okay. Now, like, so now that we can now assume that since kinetic energy is 0 at the top, my potential energy at the top is what? Because if we know that my the total energy at the top is 1960 joules, right? And we know that energy at the top, the formula for it is P plus KE. Well, if my kinetic energy at the top is 0 and my energy at the top is 1960, well, guess what? Your potential energy at the top is also 1960 joules. And so that's the answer. I'm sorry, I got interrupted. 14. Again, this problem involves conservation of energy. So what is your potential energy at the bottom? So your potential at the bottom, if your height is 0, well, then your potential energy is 0. And so, well, what is the formula for kinetic energy? It's 1/2 mv squared, right? So solve for Ke at the bottom. And so the problem gives you the velocity at the bottom. So your velocity at the bottom is 12 meters per second. All right, so 1/2 1 and 12 squared, right? Because that's your velocity at the bottom. So 1/2 144, and you're gonna get 72 joules. So that's your kinetic energy at the bottom. Now, your total energy at the bottom must equal to the total energy at the top. Well, if you know that your total energy is P plus Ke, right? You know potential energy at the bottom is 0 and your kinetic energy at the bottom is 72. Well, your total energy here is 72 joules. Now that we have this, so we're actually going to raise this. The only thing we're going to carry over is your total energy is 72 joules. So what is your speed at the top, right? What is your speed at the top? Well, speed at the top is 0, right? Because you initially dropped it. So what's your kinetic energy at the top? Your kinetic energy at the top is 0 as well. Well, guess what? If my energy at the bottom, right? If energy at the bottom, if my energy at the top is equal to energy at the bottom, and energy at the top must equal to 72 joules, and we know that energy total is P plus Ke, right? 72 is Pe plus Ke. We know that kinetic energy at the top is 0. Well, I guess all our energy is potential energy now, right? So now we move on. Just 11 more questions ago. 15. A 5 kilogram mass is moving at a velocity of 5 meters per second. What is the total work that must be done on the mass to increase its speed to 10 meters per second? So this is your initial velocity, and your final velocity, you want it to be 10 meters per second. And so these are your three knowns right here, and you're solving for your work. Now, the formula for work on your reference table is delta ET, and we know that delta ET is, well, is delta PE plus delta KE plus delta Q. Okay? And so since this is a horizontal surface, you don't really have a change in height. And if you don't have a change in height, guess what? Well, change in potential energy is mg delta H. And well, your change in potential energy is 0. And since the surface is frictionless, you're not losing any energy due to heat, right? So your change in Q is also 0. And the formula for kinetic energy is 1 half mv squared. 1 half mv squared, right? Um, can I? Yeah, I can. Hopefully you guys remember this. So your formula for kinetic energy is 1 half mv squared. So we know that change in kinetic energy is kinetic energy final minus kinetic energy initial. All right, so 1 half mvf squared minus 1 half mvi squared. And we know that your knowns, your vf is 10 meters per second, your vi is 5 meters per second. All right, so 1 half, m is 5, right? M is 5. Let's do 5. Vf is 10 squared plus 1 half 5, 5 squared. So 10 squared is 100, times 5 is 500, times a half is 250. Oh, this is actually a negative sign right here. Minus 5 squared is 25, times 5, 125, 62.5. So the answer is, and well, that's your change in kinetic energy. And we also established previously that your change in potential energy is 0, and we established that your change in internal energy is 0. And if we know that, well, my work is delta ET is equal to change in PE plus change in KE plus change in Q. It's like once 187.5. I think so. Yeah. Well, if change in P is 0 and change in KE is this right here, we just solved for it, and change in Q is 0, well, guess what? Your work done is literally just this number right here because everything else is 0. That's your work done. I'm gonna pause for a bit. Well, the video is still going. Pause for it. Actually, that's a lie. That's a lie. 16. A shopping cart. A shopping cart slows as it moves along the level floor. The floor is level. Does the height of a cart change as it moves across the floor? Again, if you're moving horizontally, you don't really change your height. So your height is 0, right? Does the height of the cart change? No, it doesn't change. No change. Or you can just write no, to be honest. Well, so what is the formula for gravitational potential energy? And it's mgh. And so does potential energy of the uh does it potential energy change as well? Then no, it doesn't really change. So your formula for kinetic energy is 1 half mv squared. Alright, so if your cart is slowing down, does the kinetic energy increase, remain the same, or decrease? Well, if you're slowing down, your velocity decreases. And if your velocity decreases, well, then your KE decreases as well. Decreases as well. So 17. As a student walks downhill at a constant speed, his gravitational potential energy does what? Well, if you're walking downhill, your height decreases. Well, if your height decreases, if your height decreases, and we know your formula for potential energy is mgh, well, then your potential energy is going to decrease as well. And so is the student speeding up, slowing down, or walking at a constant speed? Well, he's walking at a constant speed, right? If he's walking at a constant speed, v doesn't change. V doesn't change. And your formula for kinetic energy is 1 half mv squared. Well, guess what? If your student is walking at a constant speed, his kinetic energy, does his kinetic energy increase, remain the same, or decrease? Well, if your velocity doesn't change, your mass doesn't change, then your kinetic energy doesn't change as well. Alright, it doesn't change. Alright, cool. 18. Let's move on. 2 Newton baseball, so your mass is actually, since this says 2 Newtons, you already know it's giving you your weight already. Right? 2 Newtons is your weight. So a height of 20 meters. Kinetic energy of the ball is 36 joules. Maximum amount of mechanical energy converted to internal energy during the fall is what? Alright, so again, this deals with conservation of energy. And the total energy of a particular object at a certain point in time is your potential energy plus kinetic energy plus Q. So what is your velocity at the top? Your velocity at the top is 0. And so what is your kinetic energy at the top? Well, we know that kinetic formula for kinetic energy at the top is 1 half mv squared. And so this known right here is at the bottom. So we know that your kinetic energy at the top is 0. The ball hasn't moved yet. So you know your Q is 0 as well. Alright? So what is your total energy at the top? Again, we know total energy is PE plus KE plus Q. And well, if we know that K is 0 and Q is 0, we know that your total energy at the top is just your potential energy. And so your potential energy is just mgh, and mg is just fg, right? Because that's a formula. Fg is mg. And so it gives you Fg up there, so 2 newtons times 20, and you're going to get 40 joules. Alright, so that's your total energy at the top. Well, then your total energy at the top must equal to your total energy at the bottom, right? So you know your total energy at the bottom is also 40 joules. E bottom is 40 joules. So what's your height at the bottom? Your height at the bottom is 0. Well, if your height at the bottom is 0, we know that potential energy at the bottom must also be 0. Well, the problem gives you kinetic energy at the bottom. Your kinetic energy at the bottom is 36 joules. Well, now we just set up our equation. So E is 40, P is 0, K is 36, plus Q minus 36, minus 36. 4 joules is your internal energy. So you lost 4 joules of energy as you went to the ground. Now, as a block 19, as a block slides across a table, its speed decreases while its temperature increases. So what is the formula for kinetic energy? Okay, what two changes occur in the block's energy as it slides? So what is the formula for kinetic energy? We've done this so many times now. The kinetic energy is 1 half mv squared. So if your speed decreases, as the problem says it does, if your speed decreases, well, your kinetic energy must decrease as well. Alright? So that answers prompt 2 and 3. So as your temperature increases, right, because the problem says your temperature increases, I'm actually going to abbreviate as T. So if your temperature increases, your internal energy of the block is going to increase as well, right? Because you're losing kinetic energy due to friction and you're heating up the ground. It's actually similar to that GIF I showed you guys of the bicycle braking, where the kinetic energy of the bicycle decreases, it kind of creates like that the heat temperature. You saw the temperature of the floor increase along the bicycle's path. A block initially at rest is 0. So your horizontal force is 15 newtons. So your work is 30 joules. kinetic energy of the block increases by what? No, so again, involves the work energy theorem. So if the surface is horizontal, does your height change? No, your height doesn't change. It's horizontal, right? It doesn't change. Doesn't change. You can actually just write no or zero. So what is the potential energy of the object? So does the potential energy of the object change as a result? Well, we know change in potential energy requires a change in height. And well, no, it doesn't change either, so it doesn't change. A- And so the surface is frictionless. So do you lose any energy due to heat if your surface is frictionless? No, so your Q is zero. And so you can say that no, it doesn't lose energy. And so is there a change in internal energy? No, your change in internal energy is zero. So it's no for both prompts through 4 and 5. So you work in the problem right now. So you work in the problem right now is delta ET is equal to delta PE plus delta KE plus delta Q. And if you know your delta PE is 0 and you know your delta Q is 0 and you know your work done is dirty, guess what? Well, your work is change in energy, right? And you know change in PE plus change in KE plus change in Q. And work is dirty, so you know your change in P is 0, and you know your change in K, well, you want to find out change in K, and you know your change in Q is 0 as well. If you just solve for this, you just get change in kinetic energy is 30 joules, and that's the answer. 21. A 1 kilogram a ball, mechanical energy lost by the ball as it bounces is what? So your mechanical energy is the total energy of the system. If no energy was lost, the ball should come up back up to the same height. But in the problem, it says it does not. So you can actually figure out how much energy was lost by calculating the potential energy at 10 meters high versus 6 meters high. So the difference between the potential energies is the energy lost by the ball. Okay, so at a height of 10, your potential energy is mgh, right? So m is 1, G is 9.8, and H is 10, and we're around 9.8 to 10. So I'm going to do 1 times 10 times 10, I'm going to get 100 joules. And now when my height is 6 meters, well, my potential energy is also mgh. My mass is still 1, my gravity is still 9.8, and my height is 6 this time. So again, I'm going around 9.8 to 10. So 1 times 10 times 6 gives me 60 joules. Well, I lost 40 joules here. I lost 40 joules. I lost 40 joules here. So that is the lost energy. 22. Your mass is 0.100 kg. Falls from rest. So your initial velocity is 0. And your tabletop is 1.5 meters high. Okay, and it says this, so let's actually answer the prompts first. So what is the velocity of the cup at the top? Well, your velocity of the cup at the top is 0. So what is your kinetic energy at the top? Your kinetic energy at the top is 1 half mv squared. Alright, so 1 half 0.1 v squared is 0. And since you have no velocity at the top, well, your kinetic energy at the top is 0 as well. The cup hasn't moved yet. So your energy loss, you didn't even lose energy yet. So your Q at the top is 0 as well. So you're gonna solve for total energy at the top now. And that's what this formula is. Right? That's total energy at the top. So P is mgh, and your K is 0 and your Q is 0. So your total energy at the top is just mgh. And so let's actually solve for that. So 9.8 and your height is 1.5. Well, let's round 9.8 to 10. 10 times 0.1 gives you 1. times 1.5 gives you 1.5 joules. And so that's your total energy at the top. Well, we know my total energy at the top must equal to my total energy at the bottom. So my total energy at the bottom is also 1.5 joules. So that's the only thing we need to transfer over. Energy at the bottom is 1.5 joules. So now what's my height at the bottom? My height at the bottom is 0. So my potential energy at the bottom, because this is its formula, is 0 as well. And so now we want to set up uh, our total energy formula for at the bottom. We know my total energy at the bottom is 1.5 joules. We know my potential energy at the bottom is 0. We know our kinetic energy at the bottom is 1 because it tells us that in the problem. And my Q is just Q because that's what we want to find out, right? We want to solve for the energy lost. And now, well, minus 1, 0.5 joules, and I get Q. And so I lost 0.5 joules. And on your paper, I think you can just round it to, I think it's rounded to, what is it rounded to? Maybe 0.47 joules, somewhere around there. Somewhere around there. So 23. A ball is dropped from the top of a cliff, which graph best represents the ball's total energy. A lap signs the ball falls to the ground. And I told you, your total energy at the top must equal to your total energy at the bottom. All right. And so over time, it doesn't matter where you are, right? If the ball drops here, let's say your potential energy is 50 and your kinetic energy is 0, and here your potential energy is 30 and your kinetic energy is 20. Potential energy here is 20 and kinetic energy here is 30. Guess what? Your total energy never changes. Your total energy stays the same throughout time. And so the only graph that represents that, and I think this is the right dimensions. Let me actually open it. Yeah. The only graph that represents this is my total energy stays the same over time, right? Stays the same over time. And so that's the correct answer. Again, you're not destroying energy. Your total energy in a closed system will always remain the same. Problem deals with the work energy theorem. What's my total energy at the top of the incline? So you know your force due to gravity, right? It says your weight is 40 newtons. You release it from rest on an incline 8 meters above the horizontal. So your height is 8, actually 8, and that's a pretty scuffed 8. I'm gonna redraw it. So that's 8. So at the bottom, right, Q at the bottom, it's saying your internal energy lost at the bottom is 200 joules. So your total energy at the top of the incline is P plus KE plus Q, right? So, and you know you want to solve for Q, you know that your kinetic energy at the top is 0, right? Because your initial velocity is 0, and we know KE is m 1/2 mv squared. So you know your energy at your kinetic energy at the top is 0. You know you haven't lost any energy yet, because you haven't moved anywhere. You haven't lost any energy, and so you know your potential energy is mgh or fgh, because fg is mg, right? Fg is mg, and if pe is mgh, well then you're gonna substitute fg into it, right? And so your total energy here is 40 times 8, and you get 320 joules. So that's your total energy at the top. And that's also your total energy at the bottom as well, right? Your total energy at the bottom must also be 320 joules. Now, now that we have energy at the bottom, energy bot is equal to potential energy at the bot plus uh, plus kinetic energy at the bot plus Q at the bottom. So energy at the bottom is 320 joules. Okay, we solved that. Let me make sure. Yes, we did. Yes, it is. Your potential energy at the bottom is 0. Guess what? Your height is 0. So your potential energy must be 0 as well. And we want to figure out where our kinetic energy at the bottom is. And so we know what our Q at the bottom, right? It tells us in the problem your total energy lost is 200 joules, right? As it slides down. So plus 200 minus 200. Right? We want to solve for Ke is 120 joules is equal to Ke at the bottom. All right, so that's our answer. Our kinetic energy at the bottom is 120 joules. Hopefully that helped.